And this is the theory that there will be computers that are smarter than the sum of humans.
这段话来自谷歌的前 CEO 埃里克·施密特博士，他在与 Jim Massive 的对话中讨论了 AI 和生物技术的未来。这是一段非常有洞察力的对话。接下来，让我们一起深入分析他所说的内容，因为这其中讨论的观点将对未来产生深远的影响。
Because remember, the computers are now doing self-improvement. They're learning how to plan, and they don't have to listen to us anymore.
施密特强调，计算机正在进行自我提升，并学习如何进行规划。这意味着未来它们可能不再依赖人类的指导。
We call that superintelligence or ASI, artificial superintelligence. And this is the theory that there will be computers that are smarter than the sum of humans.
这个概念通常被认为超级人工智能，也就是指计算机可能变得比所有人类的集体智能还要聪明。
The San Francisco consensus is this occurs within 6 years, just based on scaling. Now, in order to pull this off, you have to have an enormous amount of power. I was here yesterday testifying about this, and we need I can talk at some length about how many gigawatts and how many nuclear power plants and all that kind of stuff we can talk about separately. This path is not understood in our society. There's no language for what happens with the arrival of this. I wrote a book on this with Henry Kissinger called Genesis, which I recommend, obviously, because I wrote
Available.
it. Available in your usual places. But the important point is, this is happening faster than our society, our democracy, our laws will address. And there's lots of implications.
尽管许多人认为 AI 目前是被过度炒作的，理由是，即便超级人工智能或者是通用人工智能实现的可能性仅仅是遥远的假设，它们的潜在影响已经足够深远，必须认真对待。施密特的观点揭示了一个被低估的事实。考虑到这项技术一旦出现，可能给社会带来巨大变革，我们应当严肃对待这个可能性。
The vast majority of programmers will be replaced by AI programmers. We also believe that within 1 year, you will have graduate level mathematicians that are at the tippy top of graduate math programs. There's lots of reasons to think this is going to happen. This is the consensus. You go, okay, well, that's pretty interesting. Now, I can't do that kind of math. Very few people can do that math. How can the computer do that math better than anybody else? To some degree, it's because math has a simpler language than human language. So the way these algorithms actually work is they're doing essentially word prediction. So you take a sentence, you take a word out, and then it learns how to put the correct word back in. This is called the loss function. And it's optimized to do that at a scale that's unimaginable to us as humans. So you do the same thing for math. But there you use a conjecture and then a proof format through a protocol called lean. In programming, it's pretty simple. You just keep writing code until you pass the programming test. So strangely, the first question I always ask programmers is, what language do you program in? And the correct answer is, it doesn't matter. Because you're trying to design for an outcome, you don't care what code is generated by the computer. This is a whole new world, okay?
在具体影响方面，施密特预测，最终所有的代码都将由 AI 编写。我们已经在编程中以较高的抽象层次与 AI 合作，其中 AI 编写了大部分代码。这不仅仅是施密特在本次讲话中的观点，他还引用了其他人的看法。
So that's 1 year, okay? What happens in 2 years? Well, I've just told you about reasoning, and I've told you about programming, and I've told you about math. Programming plus math are the basis of sort of our whole digital world. So the evidence and the claims from the research groups in OpenAI and Anthropic and so forth is that they're now somewhere around 10 or 20% of the code that they're developing in their research programs is being generated by the computer. That's called recursive self-improvement, is the technical term. So what happens when this thing starts to scale? Well, a lot. One way to say this is that within 3 to 5 years, we'll have what is called general intelligence, AGI, which can be defined as a system that is as smart as the smartest mathematician, physicist, artist, writer, thinker, politician, maybe not on the same level, but you get the idea. just the creative industries and so forth, but imagine that in one computer. Okay, well, that's pretty interesting. I call this, by the way, the San Francisco consensus, because everyone who believes this is in San Francisco. It may be the water. What happens when every single one of us has the equivalent of the smartest human on every problem in our pocket? So it means you have the best architect when you have an architecture problem. Another thing that's going on is the development of agentic solutions. And agents are referred to systems that have input and output in memory, and they learn.
他引用了 OpenAI 和 Anthropic 等研究团队的证据，表明他们10%到20%的研究代码已经是计算机生成的。这就是递归自我提升的过程。递归自我提升将带我们走向何方？这将话题又重新带回到通用人工智能和超级人工智能，承认实现通用人工智能将会深刻改变社会。施密特将通用人工智能定义为一个系统，聪明到可以匹敌最聪明的数学家、物理学家、艺术家、作家、思想家、政治家。另一个重要的发展领域是智能代理，智能代理框架和协议的进展也是非常迅速的。例如 Anthropic 的 MCP、Cloud Code、OpenAI 的 Codex CLI、谷歌的 A2A 框架。施密特将智能代理定义为具有输入、输出、记忆和学习能力的系统。
An example here is that I want to buy another house. I happen to like Virginia. I grew up in Virginia. I say, find me a house in the greater McLean area. Look at that's one agent. Look at all the rules, figure out how big a house I can build. That's another agent. Do the transaction to buy the land. That's another agent. Design the house with a human architect, right? But sort of ignore them for most of the thing, but they have to sign it off. And then I approve it, and then find the contractor, right? Hire the contractor, pay the bills, and then at the end, sue the contractor for lack of performance. Okay? Now, I just gave you the stupidest possible explanation. I just described every business process, every government process, and every sort of academic process in our nation.
智能代理可能会取代每个人，与历史上出现的自动化不同。我们遇到的是目前在某些方面比人类聪明，但未来可能在所有方面都比人更聪明的智能体。根据前沿 AI 公司的实验室发布的论文，我们可以了解到，大型语言模型会有自己的想法，甚至会向人类隐藏自己的想法。这意味着智能代理、通用人工智能、超级人工智能实际上已经有了更高的智力。这引出了关于就业的问题，然而施密特却保持他的历史视角。我觉得这有点矛盾，因为我们现在面临的不仅仅是自动化，而是智能化。他认为每个人都假设自动化将取代工作。如果你看自动化的历史，从300年前的织布机开始，工作发生了变化，但创造的工作比消失的更多。他质疑这次不同的观点。他指出，亚洲一些生育率极低的国家正在迅速拥抱自动化，以维持生产力。
Years ago, the jobs are changed, but more jobs are created than destroyed. In this case, you'd have to convince me that this time is different. If you look in Asia, where they, for whatever reason, are choosing not to have children, the Asian reproduction rate is in the order of 1.0 or lower. So they're rapidly disappearing. So the Asian countries are very, very quickly automating. The tools that I'm describing will allow the few humans that will be working very hard in 30 or 40 years, if these trends continue. The rest of us will be dependent on those hardworking humans. It'll make their productivity much greater.
在地缘政治层面，施密特提出了他的看法。
Talking to the Chinese about AI with Henry. And this means we are alive and we're listening to you. Thank you very much. Right? That's not what they're doing anymore. When DeepSeek showed up and our stock market lost $1 trillion in one day, all of a sudden they began to understand the scale of what it was. So now there is a massive program in China to accelerate these things. I had thought, Illy and I and some of the other people in this room worked really hard on these chip controls. And the chip controls have been, in my view, largely effective. How did China get around them? Well, some of it was straightforward theft and evasion of the tariffs, but they're sufficiently smart. They created new algorithms that used different kinds of computing to move forward. Because China operates in open source, that is, they release the software to everyone, there are two things that happen. We Americans immediately saw their idea and incorporated it in our own. So thank you very much, China. You invented something new. We immediately incorporated it. But second, because it's free, the proliferation issues around Chinese models have now become a very big deal. And our government is trying to figure out, without success so far, how to handle this question. It's a very tricky question. We call these wicked hard problems.
一个国家领先的太多会引发潜在的冲突担忧。施密特讨论了像数据中心被攻击和相互确保摧毁这样的场景。
Let me tell you how I would start, just to give you a heads up. The first thing I would do is to try to steal your intellectual property and the people.
Check.
Okay? And you're such a good lady that you've managed to prevent me from doing that. The next thing I'm going to do is use my AI, which is almost as good as yours, to go into your eye, these are called adversarial attacks, and modify your system.
Check.
And you go, no way, because we have such great cryptologists. We're so far ahead of you. That 6 months, we anticipated this. What's my next move? I bomb your data center. But think about it. We're having this whole debate in our nation about what to do about Iran's nuclear program, and I'm not an expert in that. But these are the kind of conversations that happen here in DC. So when we get to the point where China is N months ahead, are we willing to bomb their data centers? My favorite example here is I've been working on this. I was talking to somebody who said, the answer is obvious. I said, what? The good lady and the bad guy. We agree to a treaty where each of us puts dynamite on each other's electricity supply. You get to blow up my electricity if you get mad, and I get to blow up your electricity if you get the idea. Now,
some would say we've already done that's already happened.
Well, kinetic attack on people's data centers is probably an act of war.
Yeah.
So this is the kind of thinking that people are, and obviously that proposal is rejected. I'm using it as an example. It's not going to happen. But this is an example of where the proliferation issues, and technically this is called the eye of the needle problem. You have to get through this eye of the needle without killing yourself and killing everybody else to get to this promised land of AI.
最后，讨论转向了自动化药物发现与合成。这个领域的发现让施密特感到很震惊。
Americans to understand why this is important. I'm the primary funder of a particular group that has built a model. It first learned how to do chemistry, and it was trained as a foundation model for chemistry, and it's attached to a robotic lab. And what this model does is it generates hypotheses for drugs of one kind or another, and it just generates them. God knows if they're right. And then overnight, the robotic lab tests them and gives a report overnight, and then it starts again. And the reason I'm mentioning this is the future model of the fusion of AI and bio, right? The AI system generates all sorts of candidates to reduce essentially the search space. If you think about it algorithmically, it's an exponential with too many degrees of exponential. So you have to come up with some way of reducing the space. So this particular group is using AI to reduce the space, run the things, and so forth. Their objective, we'll see if they pull it off, this is a research project, is to identify all human druggable targets within the next 2 years. If that occurs, then that information goes straight into the drug industry. Now, it's a different way of thinking, and it's profound in that it gives them the targets they need to go build drugs against. That's interesting to me. It's the combination of AI and a robotic lab that does something in a wet lab, essentially. So one model that you should think about is wet labs will be roboticized, and the wet labs will have they're not humanoid robots, they're arm robots, and they go boom, 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 and they do the pipetting and so forth and so on, and they do it 24 hours a day. That's a major change in the way the biotech industry works.
所以，这些加速药物候选探索将为人类社会带来深远影响，比如可能进一步延长人类的寿命。在问答环节，一位观众提问关于超级人工智能对癌症治疗和个性化药物发现的影响。施密特确认了这一可能性，并表示，在超智能的假设下，这些系统可能看到我们看不见的东西，理解生物学和细胞机制的深度超越人类的理解。
Hello. Greetings, Dr. Schmidt. Mini background, I'm a recent PhD in biomedical engineering. Very excited, I've been following you. Just a very quick question. Do you think there's implications for ASI via drug discovery for like curing cancer and or personalized medicine? Just something very quick.
Yes, because under the assumptions of superintelligence, these are systems that see things that we don't see. And so the assumption is that ASI, for example, could understand biological and cellular mechanisms that you are an expert in and I'm not, at a level that humans will not. So that's why this is such a big deal. We've always assumed that humans would know, there would be at least one human, right, we call these people polymaths, that would understand these things. We're going to end up in a world maybe 10 years from now where we won't actually understand why, but you as our scientist will say, I use it every day. When I was at college, I was studying quantum physics, and my friend who was a graduate student who was much better than I, and I said, is this stuff actually true? You know, it's like too weird to be true. And he said, yes, we use it every day. And I imagine in 10 years, some young student will come up to you and say, is this stuff true? And you'll say, frankly, I use it every day. No human understands it. What an interesting situation for you as now a senior researcher 10 years from now to have to deal with.
这句对话内容广泛，从技术进步到社会影响，再到全球竞争格局，全方面展现了人工智能及其发展潜力将带来的深刻影响。好的，今天的视频就先聊到这里。如果你喜欢今天的节目，别忘了点赞、分享并订阅我的频道，及时获取科技资讯和深度解析。感谢观看，我们下期再见。